Two-stroke engines are still being used today, for example in go-karts, as they are lighter and more cost-effective than four-stroke engines. We will explain a two-stroke engine with a simple carburetor. The construction is similar to four-stroke engines. The two-stroke engine has one piston. The crankcase is used for the gas exchange. There are also a spark plug as well as intake and exhaust ports. A crucial difference is the presence of the transfer port. Let's take a closer look at the individual strokes. In the first stroke, fresh fuel-air mixture is drawn in via the intake port. It is shown here in red. It is added to the existing mixture in the crankcase. At the same time, the mixture is compressed in the combustion chamber and finally ignited by the spark plug. The second cycle starts. The hot air expands and presses the piston downwards, reducing the volume of the crankcase. Because of that, the mixture is forced into the combustion chamber. At the same time, the fresh mixture forces the exhaust fumes out. Now the cycle starts all over again. The volume reduction in the crankcase can be very easily explained using small spheres. The spheres represent the fresh mixture. The mixture is sucked into the crankcase through the piston moving upwards. When the piston then moves downwards, no additional fresh mixture flows in and compression takes place because the volume of the crankcase is decreased. As a result, the fresh mixture makes its way into the combustion chamber via the transfer port. The engine shown here operates according to the principle of cross-flow scavenging. Intake and exhaust port are on opposite sides. The deflector piston is formed in such a way that the incoming fresh mixture can successfully push out the exhaust fumes. Uniflow scavenging is another type of scavenging used. For example, in opposed piston engines, two pistons operate in only one cylinder. Here, one piston controls the fresh mixture flow, whereas the other controls the emission of exhaust fumes. This system is expensive and was used in tanks, but also frequently for large marine diesel engines. Modern engines uses loop scavenging, which is used, for example, in the famous Simpson mopeds. It is still used in many engines today. For the sake of simplicity, the crankcase and housing cover are not shown. There are various ports in the cylinder, including an inlet port. The fuel-air mixture is fed to the inlet port via the carburetor. The piston, moving up and down in the cylinder, opens and closes the inlet port consistently. When the inlet port is opened, the mixture is able to flow in. The mixture is then forced into the transfer ports by the piston. The piston closes the transfer ports and exhaust port when it travels upwards. It opens them when it travels downwards. Through the transfer ports, the fresh mixture is promoted to the cylinder and filled from the rear to the front. When the spark plug finally ignites the mixture, the piston is moved downwards and fresh mixture is able to flow in. In this process, the fresh mixture pushes out the exhaust fumes.